Dr. Benny, what are we learning today? Today, we will be talking about chemical equilibrium so that you will understand what it means and specifically how dynamic equilibrium relates to the forward and reverse reactions. In equilibrium, we are concerned about how far the reaction proceeds because when we first learn about chemical reactions, we assume that reactions go to completion, meaning that essentially all of the reactants are consumed in creating products within the constraints of the stoichiometry of the reaction. For example, hydrochloric acid reacts with sodium hydroxide to produce aqueous sodium chloride and water. If 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide, how many mole of sodium chloride and water will be produced? We would get 1 mole of sodium chloride and 1 mole of water. Exactly, Benjamin. That is what we would have expected based on the stoichiometric coefficients here. 1 mole of hydrochloric acid plus 1 mole of sodium hydroxide should give us 1 mole of sodium chloride and 1 mole of water. But in reality, many reactions do not go to completion. Only some portion of the reactants are converted to products, and then the formation of products stop increasing. So this is when the reaction reaches chemical equilibrium. For example, hydrogen gas reacts with iodine gas at 490 degrees Celsius to produce hydrogen iodine gas. Again, if 1 mole of hydrogen gas reacts with 1 mole of iodine gas, we would expect to produce 2 moles of hydrogen iodine gas according to the stoichiometric coefficients of the balanced reaction. However, we only get 1.54 moles of hydrogen iodine, which is not consistent with the stoichiometry. This suggests that the reaction does not go to completion. We did not get all of the hydrogen iodine that we may have expected to occur. Instead, we observe that reactants and products can coexist simultaneously at specific observable concentrations or pressures.